Hello everyone. In this video, we are going to discuss about Snowpro Core Certification Exam Introduction. This is an introductory video for the series of videos in which we are going to discuss about various aspects towards the Snowpro Core Certification Exam. In fact, this is the series of videos in which we are going to cover the contents which are required for you to pass the Snowpro Core Certification Exam. This is the introductory video on this specific series, so you can expect more videos on the same lines in the near future. Moving on, first thing I just wanted to engage, or I just wanted to assess myself whether am I eligible to create a video like this in a platform like YouTube. To answer that question, I'm having some decent amount of experience with Snowflake over the period of past around 6 plus years. I am having total of around 15 plus years typically in the data side, in the data engineering, data warehousing area, on which I am having close to around 6 plus years of experience in Snowflake. Currently, I am holding both the Snowpro Core Advanced Architect certifications and also Snowpro Core certification. So I sat for the Snowpro Core exam twice actually. In fact, Snowpro Core is available in the form of a recertification exam as well. So initially we need to sit for the regular certification exam, and then once in 2 years we need to renew our certification. At that time we can sit for the recertification as well. So I sat for the original exam, and then again I sat for the recertification exam, and last year I sat for the Snowpro Core Advanced Architect exam, which in turn renewed my Snowpro Core as well. So I am holding the Snowpro Core certification exam for almost around more than 5 years now actually. So I'm pretty confident that I am having some amount of knowledge on Snowflake, so that I can be an eligible person to take a course like this on a medium like YouTube. And also I am holding all the hands-on essential batches from Snowflake. If you are aware of the Snowflake hands-on essentials, currently Snowflake is offering 5 various different hands-on essentials batches. This is typically a lab environment where we need to submit our lab process to Snowflake. Snowflake can assess it and then they can grade it. If we can get the higher scores and higher grades, Snowflake will provide us with the batches. So currently I am holding all the hands-on essential batches. It includes data warehouse, data sharing, data applications, data lake, and data engineering. I am having the DCDF framework typical assessment certification as well with Snowflake. So I am currently holding all of these sorts of certifications, credentials with me. So I am somehow eligible to preach or teach this specific Snowflake certification in YouTube. So you can always reach out to me via my LinkedIn. That LinkedIn link is provided below. So if you want to connect with me, you can always reach out to me via LinkedIn. Now we are going to talk about some of the basic logistics behind the Snowpro Core exam, how the exam is going to be, how it is going to look like, what are all the total number of questions, all these basic fundamentals we are going to discuss. These details are available to us in the form of the study guide. If you can go through whatever you are seeing in the screen is the Snowpro Core study guide, which holds predominantly all the details on what you can expect on the exam, what are all the specific Snowflake related things which are tested throughout the exam, what are all some of the prerequisites which are needed. All the details are available here. Not much of this is easy for us to consume. For that reason, I took some of the contents from here and I placed it in the form of the presentation, so that it will be helpful for people to consume it in a very easy way. Now I am moving back to my presentation. Some of the basic things which Snowflake expects from the people who are going to be part of that certification exam. So the candidate is expected to have knowledge on data loading and transformation in Snowflake, must be aware of virtual warehouse performance and concurrency, must be aware of DDL and DML queries. This is the basic fundamental for any data warehouse engineer. We need to understand about semi-structured types of data, structured data, semi-structured data, and structured data. We need to be aware of cloning and time travel options within Snowflake. We need to be aware of data sharing within Snowflake, and we need to be aware of the Snowflake account structure and management. No need to worry, we are going to cover all of these details in a greater detail in the subsequent videos. Who is the target audience for this exam? They are expecting people who are having minimum 6 months of knowledge in Snowflake platform prior attempting this exam. So the familiarity with ANSI SQL is recommended. In fact, whoever is going to sit for this exam will be from data warehousing background. So typically these things are taken for granted. And what are all the prerequisites knowledge? This is already mentioned as the part of the study guide. So they are expecting the basic knowledge on database basic concepts and basics of cloud fundamentals. So all these terminologies are pretty common. Basic terminology related to databases and SQL. It's a pretty common thing. Everybody must be aware. If you are practicing data warehousing, you must be aware of databases and SQL. Tables and data types. We need to be aware of what is tables, what is views, what are all various different data types. We need to be aware of selecting and manipulating data, which we call it as ETL, typically extract, transform, load, or ELT in the form of extract, load, and transform. We need to be aware of views, stored procedures, and functions. We need to be aware of security, how the authentication, authorizations happens within Snowflake. It's a typical common basic database concepts. Since the Snowflake is an SaaS offering running on top of cloud, we need to be aware of some of the cloud details as well, which involves the cloud computing and its benefits, types of cloud services. Typically types of cloud services comes under infrastructure as a service, platform as a service, software as a service, lot of options there. I am having lot of videos on these areas in my YouTube channel. I will upload that specific videos as the part of this description link so that you can go through those videos in a clear way. And then cloud computing architectures, we need to be aware of what is storage and compute. Anyway, we are going to discuss in more detail about these things in the subsequent videos and also in the same video as well. Now again, coming to some of the other logistics related to exam. If you are attempting the Snowpro core exam for the first time, you need to sit for the exam, which is going to have 100 questions. Recertification is slightly different. The number of questions will be reduced in the recertification, but this course is mainly for the first timers. So we can assume you as a person who is trying to attempt this exam for the first time, so you can expect 100 questions in the exam. Typical question times are multiple select and multiple choice. I hope you can understand multiple select and multiple choice. Multiple select is all about checkboxes. So for the given single question, you can expect multiple correct answers. Multiple choice is the radio button type. For a given question, only one answer can be correct. So you can expect questions in both these areas. So what is the time limit? Time limit is 115 minutes, which is closely lesser than 5 minutes for 2 hours. The languages are English and Japanese, so typically we can attempt this exam in the English language. And what is the passing percentage is 750 plus on the scaled scoring methodology. Again, scaled scoring concept itself is a completely different concept. I am having a video there. I will attach the link for that video as well, how the scaled scoring works. So we need to gain 750 plus out of 1000 in order to pass this exam. Typically, on a way, how we can understand this is 75% and above. It's not perfectly correct, 75% and above, but we can assume that we need to make 75 questions out of 100 correct, then we can pass this exam. Validity for this exam is 2 years. Pretty sad, but this is the fact. Snowflake is instructing people to sit for this exam once in 2 years. Typically, you can take the recertification. No need to sit for the original exam again. You can sit for the lesser version of exam with lesser questions and lesser money as well. What is the cost involved? It is 175 plus USD currently, and you need to pay the extra taxes as well. It's a pretty slightly on the higher side of the exam. Higher side in terms of the cost. Simple math, if you do simple math, 100 questions in 115 minutes, approximately we are going to have 1 minute and 15 seconds for each and every question, or in turns we can say 75 seconds for one question. It can be doable because the question complexity is not that much complex. We can attempt this within 75 seconds. And the domain breakdown for the exam. This is very important. We need to understand this in a greater way. If you can see, this is the breakdown of the domain which is provided as per the Snowpro course study guide. So predominantly most of the contents, almost around, if you take questions base, almost around 25 questions is covered under Snowflake data, cloud features and architecture. They are claiming, Snowflake is claiming themselves as the Snowflake data cloud. So there is no different jargon. The Snowflake data cloud is always a Snowflake actually. So account access and security holds 20%, performance concepts holds 15%. So since it's a 100 questionnaire, so we can simply do one simple math and we can arrive to number of questions which we can expect. So the key areas which holds more weightage, you need to give more weightage towards those specific areas, right? Now, as we saw the logistics behind all these things, with respect to what is the exam, what is the total number of questions which comes in the exam, what is the total cost, what is the exam breakdown and everything. So as the introductory video, I don't want to keep it in a logistic way. I just wanted to start with the Snowflake fundamentals first. So in this video, we are going to discuss about Snowflake architecture. What exactly the Snowflake is going to offer us in terms of the Snowflake architecture. What are all the various components within the Snowflake which makes it an unique hybrid shared nothing and shared data type of an architecture. All these details we are going to discuss in a greater detail over this period of time. So this is an new, I cannot say a new architecture from Snowflake. This is an recent one from Snowflake which covers predominant things. If you can see, typically in the initial days, Snowflake architecture is slightly different, but this is the abstracted version of the architecture. This is not the exact Snowflake architecture. So you can see Snowflake at the bottom, which provides the intelligent infrastructure, elastic performance engine, optimized storage, all these things which is provided to us in the form of the Snowflake. On top of it, you can see SnowGrid, which is the cross-cloud offering from Snowflake. And then on top of it, you can run any of your workloads. If you want to run your data warehousing workload, you can very well run it. If you want to implement a data lake on top of Snowflake, you can very well do that. If you want to implement a Unistore on top of Snowflake, you can very well do that. Again, on the abstracted layer, you can see Snowflake can solve these sorts of industry problems. Typically, the collaboration, the data engineering, cyber security, data science, and ML. If you want to build the applications on top of Snowflake, Streamlit, lot of options are there. So you can build your own applications as well on top of the Snowflake. So Snowflake provides the opportunity to do end-to-end with respect to data. That is the reason why they are calling themselves as the Snowflake Data Cloud. So in the left side, if you can see unstructured, semi-structured, structured, any sorts of data you can see. On the right side, you can see insights, predictions, monetization, data products, and everything. It's an holistic, as I mentioned, it's an 1,000-foot top overview on what are all the options which are provided to us from Snowflake. This is not the exact Snowflake architecture. We are going to discuss about this in the greater detail in the subsequent slides. Now, slightly to the older versions. What are all the typical versions of architecture which we can see? First thing is the shared disk architecture. As the diagram represents, you can see there is a centralized place on which all your data is stored. So whatever data you want to take, you need to access it from the centralized storage location. So each and every memory and CPU associated with it, say you can take this as an individual computer or an individual compute, that computer can go ahead and it will take the data from the shared disk. So there are a lot of advantages and disadvantages for the shared disk. Typically, it's a shared disk storage. As we already discussed, the storage medium is shared across all the computer. So it helps in data sharing. It helps in the failover aspects as well. Say if I'm having this specific server down, obviously there is no problem with my data. So people can very well come ahead and then they can take the data. Say tomorrow or after some time, if this one comes up, obviously they can go ahead and take the data. So there is no problem with the outage. So failover type of the options are well safeguarded using the shared disk architecture. Other forms of the architecture is the shared nothing architecture. This is predominantly, you can see if you are aware of the MPP engines, massively parallel processing engines like Teradata, Netezza or anything, they predominantly make use of the shared nothing architecture, where you can see distinctly, you can see there is an a typical storage medium which is attached to each and every server. So I'm talking taking the CPU and memory as and combined as a server or a computer. So each and every server or node is having its own individual data disk. This is a shared nothing. So meaning this data is not shared with this specific server. This data is not shared with this specific server. That is what the shared nothing is all about. This provides a lot of other features. What are all the features? It's like you can have the event uneven data distribution among the nodes. This will help us in achieving the massively parallel processing. It's like we are having some other videos in the same areas. I will attach the links to those videos as well, where we discussed more about what is MPP, how we can achieve MPP using these sorts of architectures. So it provides better scalability, it provides better performance. These are all the key important advantages of using shared nothing architecture. Okay. Now, Snowflake is trying to combine both of these worlds, typically the shared nothing and also the shared data architecture. We want to utilize the advantages of both the architectures. So Snowflake came up with this specific architecture pattern. This is the one which I took from the Snowflake documentation, which is widely available. But to make it a very simplistic way, or to make it in a more understandable way, this is the one which provides a more detailed things. So typically, if you see, as we discussed earlier, it's an hybrid of shared disk and shared nothing. So shared disk, as we already discussed, similar to shared disk, it provides a centralized data repository which provides unified access from compute, which is achieved using this data storage layer. At the bottom, if you can see, this data storage layer will provide us the shared disk type of an architecture. So the compute layer, which we call it as virtual warehouse layer, can connect to the data storage layer, and then they can take the data from it. So it's a centralized layer which is running on top of any of the cloud. So Snowflake, as I already mentioned, it is a cloud-based data platform or a data warehouse which runs on top of predominant cloud providers like AWS, Azure, or GCP. Right? And shared nothing architecture, where you can see the individual virtual warehouses will provide us the flexibility to take the data in an individual way. That is the advantage of the shared nothing, which can be implemented using the compute layer of Snowflake. So combining both the worlds together, shared nothing and shared disk is achieved using these typical layer comparison or layer isolations in three different ways. Cloud services is a different layer, that is not a major one with respect to the typical scalability and other aspects. It's completely different. It takes care of authentication and everything. We will be going to discuss in more detail about that, right? So shared disk is a centralized data storage which is provided to us in the form of the data storage layer on top of cloud, and then the compute will be provided in form of the virtual warehouse, right? So by doing so, we are trying to combine both the worlds of shared disk and also shared nothing. Now, what we are going to do, we are going to discuss about each and every layer in a more detailed way, so that we can understand the interdependencies between the layers and also the individual layer responsibility within the Snowflake. So starting from bottom up, what is the storage layer? What is the main significance of storage layer and everything? This is the same one which I took from the previous diagram. So the storage layer is as simple as it is. It is the layer on which your data is stored. As simple as it is. It's just a storage layer where your data is stored. Typically, the storage layer will be lying on top of cloud, AWS, Azure, or GCP. So this specific data lake type of storage options is provided to us from AWS via S3, from Azure via Blob, and via GCP via GCS buckets. So Snowflake is utilizing those medium to store the data. Now, when we load the data into Snowflake, say I am taking an CSV file as an example, what it happens, Snowflake will reorganize the data to an internally optimized, compressed and columnar format. This is very important. We need to understand this in a very clear way. So when we load the data into Snowflake, what Snowflake engine does, it takes the data and then it do all this optimization work. Internally, it will optimize, it will compress, and then it will store the data in the columnar format. As you all aware, OLAP predominantly deals with columns. So typically, we need to store the data in the columnar format. Then only we can yield the benefits of OLAP, MPP, massively parallel processing and everything. Again, I am having a video which talks about the typical columnar storage. storage, I will be adding that link as well in the description. So Snowflake take the data, it will do its own operations. It is completely a black box. Till now Snowflake didn't reveal what type of optimization it is doing, in what file format it is storing. Nothing is revealed so far, so it is taken care completely by Snowflake. No need to worry. Whenever we push any data into Snowflake, Snowflake will do the optimization, right? Then data is stored in Snowflake databases in always compressed and encrypted format. This is all about data security. So the data is stored within the Snowflake in the encrypted and compressed format, which we already discussed. Snowflake automatically organizes the stored data into micro partitions. This is again another concept. We are going to discuss more about the micro partitions in the subsequent videos. So far, for the understanding, you just understand how it is storing. It is doing all compression optimizations, and then it is storing the data in the form of the micro partitions. Again, an optimized, immutable, compressed columnar format, which is encrypted using AES 256 encryption. It's a common stuff, as we already discussed encryption and everything. So it is doing it using AES 256 encryption and storing it in micro partitions. Micro partitions meaning it's a partitioning of big data. It will do simple partitions. It will chunk the data into multiple partitions, and it will store the data in the form of the micro partitions. Data is loaded into Snowflake, organized by databases, schemas, and accessible primarily as tables. That is very important. If you can see, once we do all the data loading and everything, how we can access the data in the form of a table. So whatever the data storage medium, we will define a table layer on top of it. Say if we can upload an CSV file into Snowflake, and then we can build the file format. On top of it, we will build the table. So typically using the ANSI SQL, we can go ahead and query the data as simple as is. So what are all the various varieties of data formats which are supported by Snowflake? Snowflake supports typically all actually. It supports all structured formats, it supports all semi-structured formats, it supports all unstructured formats in all these fashions: JSON, Avro, Parquet, in the document, images, and audio as well. This is a slightly trickier one. We will going to discuss about this. It is not actually storing it within the Snowflake. In fact, all the audio unstructured related documents will be stored in typical S3 or Blob or GCS, and the index and everything will be stored within Snowflake. We will be discussing in more detail in the subsequent videos related to this. Now, moving on to the compute layer. Compute layer, how it works. We discussed about storage layer, typically plain storage. When we discuss about compute, this layer is represented by Snowflake as a muscle layer. Muscle is all about power. Whatever the power you need to take the data out of the shared storage layer is provided to you in the form of an virtual warehouse. Again, an additional terminology in the warehousing concept. People from the data warehousing background, we tend to say data warehouse as a term. Data warehouse is the place where we store all the data marts and everything, but it is slightly different on the Snowflake terminology. Whenever we call it as a virtual warehouse, we are talking about the compute layer. It's an typical compute which will be provided to us in the name of the virtual warehouse. So it's a dynamic cluster of MPP compute which consisting of CPU, memory, and temporary storage. So each and every virtual warehouse will come to us in the form of an server meaning in the form of compute with enough amount of CPU, enough amount of memory, enough amount of storage as well. So don't confuse this storage with the shared storage layer. This storage depends on the size in which we are going to take the virtual warehouse. We will be discussing it. All the compute related tasks like data loading, unloading, query execution, data pipeline, ML model training and scoring will happen using this virtual warehouse layer. Why? Because the compute, the muscle power is provided to us from the virtual warehouse layer only. Now, how we can take the virtual warehouses. Snowflake is offering the virtual warehouses in the form of the t-shirt sizes. It starts from X small, medium, large, extra large till 6x large. So to understand it, how it works, say if I am taking a virtual warehouse as an X small warehouse, it comes with a single node which is an 8 core bar threads with 16 GB of RAM and 200 GB of local disk. This is very important. So So now if I can scale up to one next level, say a small, you can imagine it into two, meaning everything is doubled. So if you can take a small there, you will be having 16 cores, and then we will be having 32 GB of RAM, and then you will be having 400 gigs of storage. Similarly for medium, how it goes, you can double it, you can double the small, you will get it to medium. So it's a simple doubling x2 by which you can get it. So as simple as it is, depending on your load, depending on your power, how frequently, how speed you want to get the data out of the Snowflake, depends on that you can create the virtual warehouses. So now you can understand, it's a compute layer, it's completely independent of the storage layer. That is the power of Snowflake. So if you want to scale compute individually, you can scale the compute individually. Already the data storage layer is an independent storage. Why? Because it's already lying on top of all cloud storage, which provides all sorts of durability, all sorts of availability, right? So now coming back to the compute layer, we can scale it vertically. Vertical scaling, horizontal scaling, it's a common terminologies within the cloud ecosystem. So typically, if you can see, scaling vertically is medium to large. Say I'm currently having a medium warehouse, I want to scale it to large warehouse for more compute, for processing large amount of volumes and complex queries, it's possible. So we can scale it horizontally as well in the form of the multi-cluster warehouses. Say example, I want 3 virtual warehouses of large size. It is also possible to meet the demand of concurrency. User concurrency, we need to scale horizontally. So some terminology we need to understand. Say for more compute power, for more complex queries, we can scale vertically. For more user concurrency, we can scale horizontally, right? We can pass, and then we can resume the virtual warehouses. That is very important. So auto suspend and auto resume options are already enabled by default within the warehouse. Per second billing, that is very important. The predominant Snowflake billing goes for the virtual warehouse only. So it is based on per second billing based on the warehouse size using credits. So x small, if I take x small, can consume 1 credit per hour. So if you can take the per second, it will consume 0.003 credit per second. But there is one caveat there. For the first 60 seconds, it is built automatically. Meaning, if I am starting a warehouse now, irrespective of my warehouse termination or warehouse auto pausing, meaning say I started my warehouse, I fired a query, it ends with 3 seconds, and then I can pass my warehouse for consuming credits. But anyway, you need to be charged for 60 seconds. The first 60 seconds you need to pay for it, and then only the individual per second billing starts. In general, if you want to understand how the billing works within the virtual warehouse layer, typically 3 factors are there: number of virtual warehouses, how long they run, and size of the virtual warehouse. So we, in the SQL terminology, if you can see how we can create the warehouse, we can use some queries like this. You can use the role of sysadmin. Again, a different concept, we will discuss more about it in subsequent videos. So create a warehouse with the size of medium, auto suspend after 300 seconds, auto resume equal to true, initially suspended equal to true, meaning it will create a virtual warehouse in a medium size, and then at the initial level it will be suspended to true, so there is no charge. Whenever you fire a query against that specific virtual warehouse, then only the virtual warehouse credits will be consumed. It will move into the on state, and then it will process your query, and then it will shut down automatically based on your auto suspend feature, right? So as we discussed, it comes with all the t-shirt sizes. Actually 6x large is also there. So it starts from 1 and then multiply by 2, multiply by 2, you keep on multiplying it by 2, and finally you will end up with 256 nodes actually for 6x large, which is a very massive virtual warehouse, right? Moving on to the next layer, which is the top layer of Snowflake. We discussed about base layer, we discussed about the compute layer, which is the muscle power. We are going to discuss about the brain power of Snowflake, which is referred as the cloud services layer. Typically a brain layer of Snowflake. Why a brain layer of Snowflake? It determines, it do all the calculation for you, it do all the infrastructure management, it do all the query optimization, it do all the security related things. A complete optimization plan or a query plan is computed using the cloud services layer. That is the reason why it is called as a brain layer of Snowflake. So typically it does these features of authentication, infrastructure management, metadata management, query parsing and optimization, access control, and encryption. These are all some of the key features which it it does. But again, as we discuss, these are all needed by Snowflake to take the proper optimal decisions on query parsing and optimization. So the entire metadata is stored in this layer. The statistics about the data is stored in this layer. So if you can fire a query against that specific table, based on all those metadata information, it will generate the least expensive plan, as similar to other engines as well, right? It's a fully managed layer by Snowflake. That is very important. We are not going to do anything. In fact, we don't have much of a visibility of this layer as well. It's completely managed by Snowflake. So whenever a SQL query is sent to the query services layer, optimizer, before being sent to the compute layer for processing, right, as we discussed earlier, it does the optimization work based on the metadata which is stored there, and then it will send the query to process to the subsequent layers of virtual warehouse layer and then to the data storage layer. So some important things to see here also, you can see some caching. You can see the metadata cache, you can see the results cache, right? So what is the functionality behind this? So results cache will be storing a cached copy of your executed query results. So if you run the exact same query within 24 hours, the results cache will be used. No warehouse will be required to be active for this. Meaning, say I am having a table with 10 rows. And you shouldn't select star from table name on that specific table. Now at the initial time, it will go to the virtual warehouse, it will take the data, and then it will come back within the same 24 hours, provided there is no changes happen to the table. If I can fire the query again, select star from table name, it will not go to the virtual warehouse layer itself. It will directly throw the results from the results cache. That is the major advantage here. So there is no consumption of credits within the warehouse layer, so your charge will be greatly reduced. And then there is another stuff which we call it as the metadata cache, which is very, very important for the layer to perform, to do all the optimization and everything. As you can see, it provides the query optimization, data filtering stored in the services layer, improves the compile time for the queries against the commonly used tables. This is very important. So it's a common stuff. There is no specific relationship to the query execution, but this is the underlying metadata using which Snowflake services layer come up with the least expensive plan. Results cache is something which is very important, and there is another cache which is associated with the virtual warehouse layer as well, that will also do the same magic. Not a magic, it will do the abstraction. Say same query which is fired against it, it will not go to the storage layer. Instead, if the results are available within that same layer, it will throw it back from there. But again, that is tightly integrated with the virtual warehouse. So if we can suspend the virtual warehouse, obviously that complete data, complete cache will be thrown away. Again, it will go through. So it is completely tied to the nature of the virtual warehouse, that query caching within the warehouse layer. So these are all the typical caching. Anyway, we are going to discuss more about caching in one specific video. Right. Last final thing, what are all the ways by which we can connect to Snowflake? There are multiple ways by which we can connect to Snowflake. Typically, we use a web UI option. Web UI is the direct one which, using the URL, we can connect to Snowflake. There is an advanced version which they are calling it as the Snow site. These are all the pictures from Snow site, which provides lots of insights with respect to visualization, with respect to the data sharing. Everything is there. Data monitoring, data products, everything is available to us in the form of the single UI, which is named as Snow site. Anyway, we will discuss more about it in the subsequent videos, right? So web UI is the one of the major interfaces which people will be using to interact with Snowflake, to fire SQL queries and everything. Say if you want to programmatically connect with Snowflake, there is an option called Snowsql, where in which you can programmatically connect. You can write the command line interface commands, and then you can connect it from your command line interface, say like your terminal or putty or anything. You can connect to Snowflake and you can fire a query using the Snowsql. And native connectivity with ODBC, JDBC clients are there. So predominantly you can see most of the things are using ODBC, JDBC. So you can similarly utilize the ODBC, JDBC native connectivity to connect to Snowflake. There are some native connectors for Python and Spark as well. There is an interesting feature called Snowpark. We will discuss later about that. But you can natively you can connect to Snowflake using Python and Spark connectors. And then third-party connectors are very well available within the Snowflake partner ecosystem, like Informatica, ThoughtSpot. Lot of partners are available with Snowflake. So using the third-party ecosystem, we can very well connect to the Snowflake. right? So these are all some of the ways by which we can connect to Snowflake. So with this we come to end of this video. Just an introduction about the Snowpro core certification exam, and then we discussed about types of architectures and how Snowflake implemented the hybrid shared nothing and shared disk architecture. We discussed about the various layers within the Snowflake architecture, like cloud services layer, virtual warehouse layer or compute layer, and then the data storage layer within the cloud medium. And then we discussed about the ways to connect to Snowflake. This is the introductory video for the series of videos. We will be sharing, I will be uploading lot of videos in the same aspects with respect to the other areas which is required for the Snowpro core certification in the near future. Please do comment. That is very important for me to enhance or add more contents to it. Please do comment, do like or do dislike as well. Thank you very much for watching this video.